This is a tricky constant acceleration question. It's just one part which is 10 marks, so the question isn't breaking things down for you. We have to draw speed-time graphs for two objects, set up simultaneous equations, and then solve. There's quite a bit of algebra, so this is a question for those working towards that A or A star in maths. So we have a car starts from rest from some point A and accelerates uniformly at 1.5 meters per second squared for 20 seconds. It then continues at a constant speed. A motorbike also starts from rest from point A 10 seconds after the car has left A. The motorbike accelerates uniformly at a rate of 2 meters per second squared and eventually overtakes the car with a speed of v, and we're trying to work out that value of v. Okay, so let's represent this on a velocity time graph. We'll start with the car. We know the car starts from rest, and then it accelerates uniformly at this rate for 20 seconds. So if it's accelerating uniformly, then that means that the gradient of a speed time graph will be constant for those first 20 seconds. So then the graph of the car would look something like this, where this value of time is 20 seconds. We don't know what the final speed of the car is, what this value here is, so we can actually work that out now. We know that if we draw out a Suvat table, we know it starts from rest, meaning that u is 0. The acceleration we're told is 1.5, and this occurs over 20 seconds. That's what we're told up here. We can work out what v is from this, so we can use v is equal to u plus at. V is then equal to 0 plus 1.5 times 20. So that will end up being 30 meters per second. So that's the speed that we have here. Now for the motorbike also starts from rest, but it starts 10 seconds after the car has left A, so over here. It has an acceleration of 2 meters per second squared, so a little bit bigger than the car's acceleration. So our graph will end up looking something like this. The graph is a bit steeper. It doesn't say that the motorbike reaches some kind of constant speed in the end, so the speed will just continuously increase. At some point the motorbike overtakes the car. That would be when the area underneath the motorbike's speed time graph is the same as the area underneath the car's speed time graph. So in other words, when this blue area here, or the area underneath the blue line, is the same as the area underneath the purple line, let's say that occurs at some time t, we're trying to work out the speed of the motorbike when it overtakes the car. Okay, so how do we know that the motorbike overtakes the car when the car is traveling at a speed of 30 meters per second? How do we know that the graph looks like this as opposed to the line being steeper and crossing the velocity time graph for the car during this phase, so between 0 to 20 seconds? So how do we know that our line doesn't look like this? Well, we can do one quick calculation. If we were to consider the bike, so do a Suvat table for the bike, the initial speed is 0 as well. Acceleration was 2. Let's consider the first 20, or 10 rather, seconds of the bike's journey. So we'll work out what the speed is over here. So time is 10. We're trying to work out final speed. We use v is equal to u plus at. V will be equal to 0 plus 2 times 10, which is 20 meters per second. So this speed will be 20, so it is lower than the 30 that we had here. That's important because that means in the first 10 seconds of the bike's journey, the bike is not traveling faster than the car. In order for the bike to overtake the car, it has to travel faster than it. Remember that the bike starts 10 seconds after the car, so the car has a head start. The bike has to travel faster for some period of time before it can overtake the car. So we know that, therefore, the overtake will occur at some point when the car is traveling at 30 meters per second, as opposed to before. Okay, so now we can set up our simultaneous equations to solve this question. We know the area underneath the graph up until time t for both objects, the car and the bike, should be the same. So we can start with the car. This shape that we have over here is a trapezium. we have the base being t, this top end being t minus 20, and then the height is 30. So we can say that, so the area of a trapezium is half a plus b times h. The a plus b would be t, the bottom length, plus the top length, which is t minus 20, all times the height, which was 30. So that's the area of the trapezium. And then for the motorbike would be the area underneath that triangle. So that will end up being a half multiplied by the base, where the base would be t minus 10, and the height would be v. So this will be a half times t minus 10 multiplied by v. And that will be our equation. I'll call this equation 1. So we have two unknowns in this equation. We have t as well as v. Let's just simplify the equation first, and then we can think of what other equation we can get to solve simultaneously with this. So firstly, the two halves will just cancel out, because you have half on both sides. So this becomes 2t minus 20 times 30 is equal to, I'll expand out the right-hand side, tv minus 10v. We can expand out the left-hand side, 60t minus 600 is tv minus 10v. Okay, so this is equation 1. Now, we want to get another equation which involves t and v. Acceleration is 2, we know that. Acceleration is equal to change in velocity over change in time. So if we think about the motorbike's journey, the motorbike starts at a speed of 0. It ends up with a speed of v. So the change in velocity would be v. And this occurs over a time of t minus 10. So then the acceleration will be, change in speed will be v, change in time will be t minus 10. Acceleration is 2, so this equation becomes v is equal to, bring the t minus 10 to the right, 2t minus 20, so I'll call that equation 2. So we have two equations now involving t and v, this one and this one. So we can substitute in 2 into 1, so we put equation 2 into equation 1, so I'll replace all of the v's, these two v's here with 2t minus 20. And we end up with 60t minus 600 is equal to t times v, which is now 2t minus 20, minus 10v, which is now 10 2t minus 20. Expand, 60t minus 600 is equal to 2t squared minus 20t minus 20t plus 200. I'll bring everything to the right, so we then end up with 2t squared minus 100t plus 800. So now we're just solving this equation, so divide everything by 2, factorize t minus 40, t minus 10, and then we get two solutions. T is 10 and t is 40. Going back to our graph, so we had two options, t is either 10 or t is 40. Well, we can see from our graph that t can't be 10, that will be all the way over here. So t would be 40 in that case. So if t is 40, remember our goal was to work out what v was, that was our goal. So then we can use the equation that we have over here, v is equal to 2t minus 20. Sub in the 40 into that. So v is then 2 times 40 minus 20, which would be 60 meters per second.